Hi, good morning, my dear students. I'm Daphne. Welcome to my STPM Chemistry discussions. Today, I will continue to discuss about the reactive acidity of alcohol, phenol, and carboxylic acid. We use the concept of inductive effect and a resonant effect to explain the acidity of organic compounds. Now, let's go to the first part. What is inductive effect and a resonant effect?
My dear students, in semester 1, we compare the acidity of organic compound by using the value of pKa or Ka. In this semester, we need to determine the reactive strength of organic acids without knowing their pKa value. Therefore, we compare the stability of their conjugate bases. We already discussed part 1 in my last video. Now we will go to part 2. My dear students, the relative strength of an acid can be predicted based on its chemical structure. In general, an acid is stronger when the HA bond is more polar. Acidity is also greater when the HA bond is weaker and the conjugate base is more stable. To determine the acidity of a compound, we need to compare the stability of the conjugate bases. Always bear in mind that the more stable the conjugate base, the stronger the acid is. Since we know we need to compare the stability of the conjugate bases to determine the reactive acidity, but which conjugate base is more stable? The conjugate base contains one or more lone pair electrons than the parent acid. Any factor that stabilize the lone pair on the conjugate base favor the dissociations of hydrogen ion and make the acid a stronger acid. In STPM syllabus, we may sum up in two factors that affect the stability of conjugate bases. They are inductive effect and resonant effect. Let's see what is inductive effect, what is resonant effect. The polarizations of a sigma bonds due to electron withdrawing or electron donating effect of adjacent groups or atoms is referred as inductive effect. In this process, the electronegative atom gets partial negative charge while the other atom gets partial positive charge. There are negative inductive effect and positive inductive effect. In chemistry, the resonant effect, also known as the mesometric effect. In simple terms, we can describe that resonant effect occurs when pi electron move away from or toward a substituent group in a conjugated orbital system. This is the example of STPM past year questions. Is asking about reactive acidity of two compounds. In your answer, you need to explain the acidity of the compound with the factor of inductive effect and resonant effect. Therefore, you need to use the following keywords to write your answer. By using this example, let's discuss how are we going to use the concept of inductive effect and resonant effect to explain the acidity of the organic compound. Based on the pKa value, The reactive acidity are as follows. My dear students, what makes a carboxylic acid so much more acidic than an alcohol or phenol? The dissociations of the organic acid will produce the following conjugate bases. Now, we need to use the concept of inductive effect and resonant effect to explain why carboxylic ion is more stable than phenolic ion or alkoxide ion. At first, we need to explain the reason why the aliphatic alcohol is the weakest acid. Then explain the acidity of phenol and ethanoic acid. Now, let's look at the acidity of alcohol. Next, acidity of carboxylic acid. As a conclusion, alcohol only show positive inductive effect. There's no resonant effect. For both phenol and carboxylic acid show negative inductive effect and resonant effect. So, how to explain the acid strength of carboxylic acid is stronger than phenol?